We start building our predictive model in this first screen. Point the model at the database and tables that contain the event and monitored condition data. Those tables now appear in the tree view on the left. Now I enter the project's general information. CBM model. That would be the name of the asset, component, or failure mode whose failure behavior we wish to model. We are working with the simplest template of a single failure mode, but we could be using a complex itemed template, which models the more general case of two or more failure modes in a single asset. I'll build the model. A new entry called C Inspections appears on the tree. It combines in a single table the events with the condition monitored data leading up to those events. A learning algorithm will parse each row of this table, iteratively build a hazard rate equation. It outputs a report that shows the parameters of the hazard equation as estimated by the algorithm. We have three parameters, one for iron, lead, and the shape parameter, also known as beta in the equation. These parameters indicate the respective amount of influence each condition indicator has on failure probability. The final step in the algorithm, a third computation to optimize replacement decisions in keeping with the user's cost and availability objectives. We can consider cost or availability or a combination of cost and availability. We'll choose the simplest optimization, cost. The user supplies relative cost estimates for replacement and failure. Replacement cost, say $1,200. Failure cost, say $6,000. That gives us a graph of the average cost of ownership as a function of risk. We can look at the report to understand the optimization. It tells us that the optimal policy will reduce long-term costs by 75%. It's time to export the model to the real world where we put it to work. And here is a basic version of Appendix C as described in your request document, providing the optimal replacement times for each unit of the fleet. This version of Appendix C tells us pretty much everything the asset manager needs to know, including the optimal replacement recommendation, failure predictions, and confidence intervals. If we go back to the decision agent report, we can drill down to any unit and get all of the information we need to justify a replacement. The optimal decision graph, failure probability in the next observation interval, the conditional probability of failure, the conditional density function, and a table of failure probabilities within various future time windows. Thank you.